The 2020 National Electrical Code requires that all 120-volt, 15-amp and 20-amp outlets installed in bedrooms be protected by arc fault circuit interrupters. These devices, known as AFCIs, are designed to detect arc faults and interrupt the power supply to the circuit. An arc fault is a dangerous electrical condition that can occur when there is unintentional electrical discharge between two or more conductors or from a conductor to ground. These faults can be caused by damaged or deteriorated wiring, loose connections, or faulty appliances. The high temperatures generated by arc faults can ignite nearby combustible materials, leading to electrical fires. Therefore, AFCIs are essential safety devices that help to prevent electrical fires by quickly de-energizing a circuit when an arc fault is detected. Now let's consider the specific requirement for AFCI protection in bedrooms. The reasoning behind requiring AFCI protection in bedrooms is because bedrooms are locations where people are typically sleeping and may be less likely to detect a fire in its early stages. Ensuring electrical safety in these areas is particularly important to protect occupants from potential hazard. The code specifies that all 120-volt, 15-amp and 20-amp outlets in bedrooms must be AFCI protected. This requirement applies to all types of outlets, including receptacles, lighting outlets, and any other point in a wiring system from which electrical current is drawn to supply utilization equipment. To meet this requirement, a listed AFCI circuit breaker must be installed in the electrical panel protecting the branch circuit that serves the bedroom outlets. These breakers are designed to differentiate between normal arcing that occurs during the operation of certain devices, such as motors, and dangerous arc faults that indicate a problem in the wiring system. When an arc fault is detected, the AFCI breaker quickly trips, cutting off the power to the circuit and preventing a potential fire. Now let's talk about smoke detectors. While the NEC requires AFCI protection for bedroom outlets, it generally does not mandate that smoke detectors be connected to an AFCI protected circuit. Smoke detectors are life safety devices that are designed to provide early warning of a fire. These detectors use various technologies, such as photoelectric or ionization sensors, to detect the presence of smoke particles in the air. When smoke is detected, the alarm sounds, alerting occupants to the potential danger. Although the NEC does not typically require smoke detectors to be on AFCI circuits, it is important to note that the authority having jurisdiction, or OJ, may have additional requirements. The AFCI is the governing body responsible for interpreting and enforcing the electrical code in a specific geographic area. This authority could be a local building department, fire marshal, or other regulatory agency. The AFCI has the authority to make amendments or additions to the NEC based on local conditions and concerns. In some cases, the AFCI may require that smoke detectors be connected to an AFCI protected circuit. This requirement may be based on factors such as the age of the building, the type of wiring system, or the history of electrical fires in the area. The AFCI may also require AFCI protection for smoke detectors in specific occupancies such as multifamily dwellings or assisted living facilities. To determine the specific requirements for smoke detector AFCI protection in a given area, it is always necessary to consult with the local AFCI. The AFCI can provide guidance on the applicable codes and standards, as well as any local amendments or interpretations. Failing to comply with the AFCI requirements can result in fines, delays, or even the rejection of an electrical installation. In addition to the AFCI requirements, there may be other factors to consider when deciding whether to install smoke detectors on AFCI circuits. For example, some manufacturers of smoke detectors recommend against using AFCI protection as it can cause nuisance tripping. Nuisance tripping occurs when the AFCI breaker trips unnecessarily, interrupting power to the smoke detector. This can be caused by normal electrical noise or transient events on the circuit. If a smoke detector is connected to an AFCI circuit that experiences nuisance tripping, it may not function properly in the event of a fire. To avoid nuisance tripping, it is important to carefully consider the compatibility of the smoke detector and the AFCI breaker. Consult the manufacturer's instructions for both devices to ensure that they are compatible and that the AFCI breaker is properly sized for the circuit. Another option is to install a smoke detector with a battery backup. This will ensure that the smoke detector continues to function even if the power is interrupted by an AFCI trip. In summary, the NEC requires AFCI protection for all 120-volt, 15-amp and 20-amp outlets in bedrooms. This requirement is intended to prevent electrical fires by detecting and interrupting arc faults. While the NEC does not typically require smoke detectors to be on AFCI circuits, the AFCI may have additional requirements. It is important to consult with the local AFCI to determine the specific requirements for smoke detector AFCI protection in a given area. The NEC serves as a baseline for electrical safety, and local jurisdictions often have the power to amend or add to these regulations based on their specific needs and risk assessments. This means that while the NEC might not explicitly require smoke detectors to be on AFCI circuits, the AFCI in San Jose or any other location could mandate it. This is often the case in areas with a history of electrical fires or in buildings with specific safety concerns. Understanding the role and authority of the AFCI is crucial for anyone involved in electrical installations. It ensures that all work meets not just the minimum national standards, but also any additional local requirements designed to enhance safety. When planning an electrical installation, it's also important to consider the potential for nuisance tripping. AFCI breakers are designed to be highly sensitive, which can sometimes lead to them tripping in response to normal electrical activity. If a smoke detector is connected to an AFCI circuit that experiences frequent nuisance trips, it could compromise the detector's functionality, especially if it lacks a battery backup. Choosing the right type of smoke detector and AFCI breaker can help mitigate this risk. Some smoke detectors are designed to be more resistant to nuisance tripping, and some AFCI breakers offer advanced features that reduce the likelihood of false alarms. Another important aspect to consider is the overall electrical system in the building. Older wiring systems, for example, may be more prone to arc faults and other electrical issues. In such cases, the AFCI might be more likely to require AFCI protection for smoke detectors as an extra layer of safety. Similarly, in buildings with a history of electrical problems, the AFCI may impose stricter requirements to prevent future incidents. Finally, it's worth noting that the electrical code is constantly evolving to incorporate new technologies and address emerging safety concerns. As such, it's important to stay up to date on the latest changes and revisions to the NEC and any local amendments. This will ensure that all electrical work is performed in accordance with the most current standards and that the safety of occupants is always prioritized. Always consult with a licensed electrician to ensure compliance with all applicable codes and regulations. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. So, to reiterate the key points, firstly, the NEC mandates AFCI protection for 120-volt, 15-amp and 20-amp bedroom outlets to mitigate fire risks. Secondly, smoke detector AFCI requirements vary. The NEC doesn't typically require it, but the AFCI might. Thirdly, understanding and complying with the AFCI regulations is paramount for legal and safety compliance. Fourthly, consider nuisance tripping potential when integrating smoke detectors with AFCI circuits. Fifthly, regular consultations with local AFCI and licensed electricians are crucial for staying current with electrical codes and ensuring safety. By adhering to these points, you can navigate the complexities of electrical codes and ensure a safe environment. Remember that electrical safety is not just about compliance, it's about protecting lives and property. The NEC 210.12b specifically deals with arc fault circuit interrupter protection in dwelling units. This section mandates AFCIs to protect branch circuits that supply 120-volt single-phase 15 and 20 amp outlets installed in dwelling units. This includes outlets in various rooms, such as family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, and similar areas. The primary purpose of this requirement is to enhance fire safety by detecting and interrupting arc faults, which are a common cause of electrical fires. An arc fault occurs when there is an unintentional electrical discharge between two or more conductors or between a conductor and ground. These faults can be caused by damaged or deteriorated wiring, loose connections, or faulty appliances. The high temperatures generated by arc faults can ignite nearby combustible materials, leading to a fire. AFCI breakers are designed to detect these arc faults and quickly interrupt the power supply to the circuit, preventing a potential fire. The NEC specifies that AFCI protection must be provided for all outlets in the designated areas, including receptacles, lighting outlets, and any other point in the wiring system from which electrical current is drawn to supply utilization equipment. This comprehensive approach ensures that all potential sources of arc faults are protected. However, it's important to note that there are some exceptions to this requirement. For example, AFCI protection is not required for circuits that supply only a fire alarm system. This exception is intended to prevent nuisance tripping of the AFCI breaker from interrupting the fire alarm system, which could have serious consequences. Another exception may apply to certain types of dedicated circuits that serve specific appliances or equipment. These exceptions are typically outlined in the NEC and should be carefully reviewed to ensure compliance. In addition to the NEC requirements, it's important to consider any local amendments or interpretations by the AFCI. As mentioned earlier, the AFCI has the authority to modify or add to the NEC based on local conditions and concerns. This means that the specific requirements for AFCI protection may vary depending on the location. For example, the AFCI may require AFCI protection for additional areas or circuits that are not covered by the NEC. They may also have specific requirements for the type of AFCI breaker that must be used or the installation methods that must be followed. To ensure compliance with all applicable codes and regulations, it's always best to consult with the local AFCI and a licensed electrician. They can provide guidance and the specific requirements for your area and ensure that your electrical installation is safe and up to code. When installing AFCI breakers, it's important to follow the manufacturer's instructions carefully. AFCI breakers are more complex than standard circuit breakers and require special attention to ensure proper installation and operation. Be sure to properly identify the circuit conductors and connect them to the correct terminals on the AFCI breaker. Also, be sure to test the AFCI breaker after installation to verify that it is functioning correctly. This can be done by pressing the test button on the breaker. If the breaker trips when the test button is pressed, it is working properly. If the breaker does not trip, there may be a problem with the breaker or the wiring. In this case, it's best to consult with a licensed electrician to diagnose and repair the problem. Finally, it's important to remember that AFCI protection is just one aspect of electrical safety. There are many other things you can do to protect yourself and your family from electrical hazards, such as using ground fault circuit interrupters, or GFCIs, in wet locations, avoiding overloading electrical circuits, and regularly inspecting electrical cords and appliances for damage. By taking these precautions, you can significantly reduce your risk of electrical fires and other electrical accidents. It is important to understand the difference between AFCIs and GFCIs. While both devices are designed to protect against electrical hazards, they do so in different ways. As mentioned earlier, AFCIs protect against arc faults, which are a common cause of electrical fires. GFCIs, on the other hand, protect against ground faults, which occur when there is an unintentional electrical path between a current-carrying conductor and ground. Ground faults can be caused by damaged insulation, wet conditions, or faulty appliances. GFCIs work by detecting imbalances in the current flowing through the hot and neutral conductors. If there is a ground fault, some of the current will leak to ground, causing an imbalance. The GFCI will detect this imbalance and quickly interrupt the power supply to the circuit, preventing a potential shock. GFCIs are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. They are also commonly used to protect circuits that supply swimming pools, hot tubs, and other water-related equipment. While AFCIs and GFCIs protect against different types of electrical hazards, they are both important safety devices that can help to prevent electrical fires and shocks. In some cases, both AFCI and GFCI protection may be required for the same circuit. This is often the case in bedrooms and other areas where both arc faults and ground faults are potential hazards. In these situations, a combination of AFCI/GFCI breaker may be used. These breakers provide both arc fault and ground fault protection in a single device. It's important to choose the right type of breaker for the application to ensure that you have adequate protection against all potential electrical hazards.